Okay, so we're going to start on geometric sequences, 12.3. So we did arithmetic sequences in the last video, and an arithmetic sequence, to get to the next term, you will add a number to the previous term. And in a sequence, it's always going to be the same number. We call that number the common difference. So if you subtract any two consecutive terms in an arithmetic sequence, you will always get that common difference. And so those kind of correspond to linear functions in that they're going up by a set amount each between each term. So in this one, we're going to talk about geometric sequences. And the key idea here is that instead of adding a constant term to each previous term, we are going to multiply something by the previous term. And so a geometric sequence would look like this, where we have the first term a, then we multiply it by r, multiply the next one by r, so that'd be multiplying the first one by r squared, then multiply the first one by r cubed, multiply the first one by r to the fourth, and so on. And so a is the first term of the sequence. R is going to be the common ratio. And so instead of a common difference with arithmetic sequences, we have a common ratio with geometric. And so the nth term of the geometric sequence would be a sub n for the nth term would be a times r to the n minus 1. So you notice the second term, r has a 1 for the exponent. The third term, r is squared. The fourth term, r is cubed, and so on. So the exponent here is always 1 less than whatever term you're on. So let's look at a couple of examples here, simple examples. So find the first 4 terms and the nth term. So the first term, of course, is given as 3. The second term, now to get to the next term, we just need to multiply the previous term by r. So 3 times 2 would be 6. 6 times 2 would be 12. 12 times 2 would be 24. So that'd be the first 4 terms. And then to get the nth term, so a sub n would be the first term times r to the n minus 1. And so then we get the 8th term or the 10th term or whatever term we're interested in. All right, so now when a is 2, r is -5, we have 2, and then the next term would be 2 times -5, so that'd be 10. The next term would be -10 times -5, so that'd be 50. The next term would be 50 times -5, which would be -250. And then the general term, the nth term, would be 2 times -5 to the n minus 1. And then this one we have a is 1, r is 1/3, so the first term is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 would be 1/9. 1/9 times 1/3 would be 1/27th. And then the nth term would be, we don't have to write the 1, so we could really just write this as 1/3 to the n minus 1. All right, I'm going to add one in. I'm going to add an example in here. So let's find, let's say, the first term. If, say, a3 is, let's say, 24, and let's say a5 is 96. I'm trying to do this in my head, so hopefully this works out. So we know, so the general form, an equals ar to the n minus 1. We're really looking for a, but we don't know what r is. We don't know what a is, so we kind of have 2 unknowns here. So we need to set up 2 equations. So a3 equals 24. So that would be ar. If n is 3, then r would be squared. And then a5 would be 96 equals ar to the 4th. So now we have these 2 equations with 2 variables, and we can probably solve these. I think the easiest thing to do, let's reverse these as far as put this one on top. So it'd be r to the 4th. and 24 equals AR squared. And let's divide here. So we know that A is not 0, so and we know that R is not going to be 0, so we're not dividing by 0 here at all. 24 divided by, or 96 divided by 24, that would be 4. The A's are going to cancel out, and then we have R squared. And so that tells us that R is going to be 2. Now it could be -2, except we know that this is an increasing, well, actually, I guess it could still be -2, but we'll assume it's +2 here. So the R is 2, and then we can figure out what the A is. So by plugging R into there, so 24 would be A times 2 squared, and so that tells us that A is 6. Okay. And so then, so that would be the first term. And then the general term, if you wanted, that would be 6 times 2 to the n minus 1. Okay, so let's look at this first one on the next page. Find the common ratio and the nth term and the 8th term in the sequence. So the common ratio, we can pick any 2 terms. It doesn't matter which 2 you pick. So R equals, just pick 45, grab the one next to it, divide those. And so the common ratio is 3. Now this one, I mean, fairly 3 times or 5 times 3 is 15, 15 times 3 is 45, so on. But if it's harder to tell, it might be harder to tell, like if your ratio is 5/8 or something like that. That one might, and you don't start at 1 or 5/8, then it might be a little bit trickier. But that's how you do it. Just pick any 2 terms that are right next to each other, put the higher term on the, and by higher term, the one that comes last. So the 3rd term over the 2nd term, the 4th term over the 3rd term, like that. So our formula here, AN, would be 5 is the first term times 3 to the n minus 1. So then the 8th term would be 5 times 3 to the 8 minus 1, or 3 to the 7th. And that is 10,935. I did that correctly. Yeah, that should be good. Okay, so common ratio, nth term, 8th term. All right, so that's good for this one. We'll get to partial sums on the next one.